In my earlier video, I had discussed some question of functional several variable which had come in CSR net exam. This example not only important for CSR net, this is also important for any competitive exam. Today I will discuss some more questions. At first I will highly recommend you please see my earlier video. Then today's video will be so easy. And then you will appreciate in functional several variable these topics. First question. Here have defined two different functions. The first function is fxy equal to 1 minus cos x plus y over x square plus y square when xy not equal to 0, 0. And when xy equal to 0, 0, 0, then the value of the function is half. And other function g of xy equal to 1 minus cos x plus y over x plus y if x plus y not equal to 0 and half if x plus y equal to 0. Then option indicate f is continuous at 0, 0, f is continuous everywhere except at the point 0, 0, and third option g is continuous at 0, 0, and fourth option g is continuous everywhere. At first I will verify the first option. Here the numerator is 1 minus cos x plus y, which is we all of us know continuous everywhere, but denominator is x square plus y square, which is also continuous everywhere except at the point 0, 0. That means we have to check the continuity only at the point 0, 0. This, consider the path y equal to x, okay, and for this path limit x tends to 0, 0, we have to point this limit f of xx, this is equal to limit xx tends to 0, 0, and fx is equal to 1 minus cos 2x. Let's put this value in y, this would be 2x square. Then after simplifying, this would be limit xx tends to 0, 0, 1 minus cos 2x equal to 2 sin square x over 2x square. Okay. Now simplify this part. Then this is equal to limit xx tends to 0, 0, sin x over x whole square, and this value equal to always 1. Okay. Here notice at the point 0, 0 the value of the function is 1, but in question it given at the point 0, 0 the value of the function is half. That means this function is not continuous at the point 0, 0. Are you getting? Because here the value is different. So our first option is a wrong option. If is continuous at the point 0, 0, this is wrong option. But second option is the right option, because here given if is continuous everywhere except at the 0, 0. Okay. And other function is g of xy. It is again question of two continuous function. So this function always continuous, only break at we have to check at the point 0. Now we have to find the continuity at the point 0, 0. At first simplify. This would be, we can write it as 2 sin square x plus y over 2 over x plus y over whole square. Okay. Now 2 sine square x plus y over 2, we can write it as also 4 times 1 over 4 x plus y over whole square, which we can write as 2 sine square x plus y over 2 over 4 times x plus y over 2 whole square. Okay. Now if we put the limit, that means limit x plus y tends to 0, g of xy equal to, here if we simplify this would be 1 over 2 equal to 1 over 2 limit x plus y tends to 0 sine square x plus y over 2 over x plus y over 2 whole square. Okay. This is also we can write as half limit x plus y tends to 0 sine x plus y over 2 over x plus y over 2 whole square. And if we calculate the limit, we all of us know this value equal to half times 1, which is equal to half. Okay. And here in the question have indicate when the x plus y equal to 0, then the value of g of xy equal to half. So the function g is continuous at 0, 0. Also, since it is quotient of two continuous function, g is continuous everywhere. Okay. That means option 2, 3 and 4 are right option. Okay. Well, now I will say another question which had come also CSR net. The question is, for any y belongs to R, let box of y denoted the greatest integer which is less than or equal to y. First know this indication, box of y. Here define a function f from R2 to R such that here the function defined as, notice, x to the power box of y. Okay. Just at first say the notation fxy equal to x to the power box of y. We all of us know this is the greatest integer which is less than or equal to 1. If you put the value x comma 1.2, then this would be x to the power box of 1.2, and this is equal to, by the rules, by the greatest integer method, this would be x to the power 1 which is equal to x. Similarly, if we put f of x comma 0.3, then this would be x to the power 0.3 which is equal to x to the power, by the rules, which will be x to the power 0 which is equal to 1. Getting why this is 0? Because box of y is the greatest integer which is less than or equal to 1, and in 0.3 the greatest value which is less than 0.3 will be 0. Similarly, for 1.2 the greatest integer which is less than or equal to 1.2, this would be 1. We all of us know this is the graph of the box function. This is also known as step function. We all of us know this is. And our given function is defined as like this. Okay, well, now let's see the option. Option 1 denoted f is continuous on R2, and option 2 denoted for every y belongs to R, x maps to fxy is continuous on R which is removed at the point 0. And option 3 indicate for every x belongs to R, y maps to fxy is continuous on R. And option 4 indicate f is continuous at no point of R2. Now for continuity, we all of us know the sequential criteria for continuity. The statement of this criteria is, just recall, if we have to prove any function is continuous at the point xy, then at first we have to choose a sequence xn yn which converges to xy. Then by sequential criteria of continuity, fxn yn should be converges to fxy. Okay, here the given function is fxy equal to x to the power box y. Okay, and in first option has given f is continuous on R2, that means whole R2. At first I will prove the continuity at the point 2, 1. Okay, for this, if we can use the sequential criteria, at first we have to choose a sequence xn yn. Consider this sequence equal to 2, 1 minus 1 over n, which converges to 2, 1. Okay, then f of xn yn by the defined function, this would be xn to the power box of yn, which would be 2 to the power 1 minus 1 over n, which is equal to, by rules of greatest integer, this would be, just think the picture, here 0, here 1, and here would be 1 over n, and here denoted box of 1 minus 1 over n. That means this greatest integer would be, the value would be 0. So this is equal to 1. Okay, but notice f of 2, 1, which is equal to 2 to the power 1, which is equal to 2. Okay, that means by the sequential criteria we cannot tell f of xn yn converges to f of xy. If xn yn converges to xy, okay, this rules has break. So this function is not continuous at the point 2, 1. So our first option is a wrong option, because here indicate f is continuous on R2. This is wrong option. Okay, and second option indicate for every y belongs to R, x maps to fxy. Here notice, for every y belongs to R means here y is fixed. Okay, And we have to prove, actually for every y belongs to R, x maps to fxy is continuous on R omitted with singleton set 0. Since here y is fixed and the function is defined as x maps to fxy, now this function, our given function for this criteria, now it will be represent only one variable. So consider the new function g from capital R to capital R such that g of x equal to f of xy, which is equal to denoted as x to the power box of y. Okay, since here y is fixed, I have chosen, consider a number k greater than 0, then box of y will be k. Then our new function will be represented as x to the power k. And notice this function. This function is a polynomial. We all of us know it. So we all of us know any polynomial function always be continuous. So when k greater than 0, then our new function g always will be continuous. But when k less than 0, then consider box of y equal to k, which is less than 0. Then g of x represent as 1 over x to the power k. This function always continuous, but only not continuous at the point x equal to 0. So when y will be fixed, this function always will be continuous, but not continuous only at the point 0. So in option 2 has indicate for every y belongs to R, x maps to f of xy is continuous on R omitted singleton set 0. This option is a right option. Okay. And option 3 indicate for every x belongs to R, y maps to fxy is continuous on R. And here notice, here x is fixed. Since here x is fixed and our new function is represented as y mapped to fxy, so consider the new function as z dash, which is represent from R to R, and the function is denoted as z dash y equal to fxy, which is equal to x to the power box of y. And now we have to prove, is this function is continuous or not? Choose a point y equal to 1, because I will use here sequential criteria, but here the one variable, so choose a point y equal to 1. Now we have to, for continuity, we have to choose a sequence. Consider a sequence yn equal to 1 minus 1 over n, and notice this sequence always converts to y as n tends to infinity. Then what would be f of yn? This is x to the power box of yn. Okay, that means this is x to the power box of 1 minus 1 over n. By previously this is equal to, all of us know x to the power 0, which is equal to 1. That means f of 1 minus 1 over n converges to 1. But notice, since here the point 1, f of 1 equal to x to the power 1, box of 1, which is equal to always would be 1. So this value equal to x. So here continuity depends on the point x. For example, if you take x equal to 3, then this new function z dash cannot be continuous at the point y equal to 1. Because here the sequential criteria has broken, because yn converges to 1, but f of yn does not converges to f of y. So when x is fixed, then the function is not continuous on whole real line. So this option is a wrong option. Fourth option also wrong option, because fourth option indicate f is continuous at no point on R2. This is also wrong option. Okay? That means only option 2 is a right option. Okay. And fourth option is a wrong option, because I have seen in second option, when y will be fixed, then the function always will be continuous, only not continuous at the point 0. Okay, see you soon. I hope this video will help you to approach any question of any competitive exam of function and variable. Stay safe and stay positive always. Okay. And if you have any inquiry about my topic, please do comment in my comments box of the channel.